So it's been a while, but today I want to talk about content events and scheduled jobs inside Optimizely CMS. I also want to do this in a somewhat real-world-ish scenario where we are integrating with an external service, and it's just a super simple demonstration service I wrote called Content Index. The service itself is not important, but I do want to talk about how we would integrate with that service. So let's jump in. I do have a couple announcements. All right, first, a quick update on the project. Quite a few people were asking for source code, and that's fine. I have it out on GitHub. This repo will be public by the time the video is published. I will have the link in the description. You can download it and kind of follow along in this repo if you like. I'll try to tag every episode with a tag name so you can have like at the starting point of the episode. The one thing I will say is don't use this as your starting point for a production website. This is not meant to be production code. It is example code. It is meant to be very simple and easy to follow, not necessarily best practices. So just keep that in mind. The other thing is that when I first created this, I wanted to use or be as realistic of a scenario as possible, as real world as I could be. So I used the Blend branding from my company, Blend Interactive. I can't really open source that. So instead, I replaced the branding with a Bootstrap template that is also open source that I found, and it's pretty simple. So it will look different going forward, but it's still the basic idea of templates, styles, that kind of stuff. And then that it is just included in the repo. You don't have to do anything, but if you're curious, I also link to it in the README. So for this episode, I really wanted to focus on like integrating content outside of the CMS, or maybe just more of a deep dive into how content works and how we can integrate with other systems. And so to do that, I've created this convoluted scenario where we are indexing content from the CMS into some kind of external content indexing system. So for this example, I actually built a very basic content indexing system that just indexes content in SQL. If you were doing this in the real world, I would strongly suggest that you use like Optimizely's now it's called Search and Navigation, formerly known as Find, Optimizely's Search and Navigation product, or Elasticsearch, Solar, almost anything other than what I built here. But the point is to kind of give you the idea of how to react to content changes, how scheduled jobs work, that kind of thing. So I don't want to go super in detail on how the content index works, but here's a very broad overview. Basically, the content index is just it's a single table, and it's a bunch of rows, and those rows represent individual bits of information about a piece of content. So, for example, the homepage has a content type of homepage. It also, due to inheritance, also has a content type of abstract page. So we're just indexing all the different content types that the homepage has. We have an About Us page that also has a text page content type and an abstract content page content type. Maybe we also have a couple of categories on that. We have an informational category, historical category, whatever. And then what we can do is we can query this table and say, give me all the pages that maybe have a content type of abstract content page. Well, that will return the homepage and About Us. This is arguably better than using some of the built-in systems for searching. Specifically, find pages by criteria. You may see that out in the wild. Find pages by criteria can be useful in some situations, but the important thing to remember is that it's querying the database directly, bypassing cache, and is not super efficient. It's really meant for like kind of one-off tasks or scheduled jobs or something where you're not running it all that often. Never use find pages by criteria on like page load, because it's going to really hurt site performance. That's where a content index such as search and navigation would come in handy. It's much faster than doing find pages by criteria. Okay, let's dive into the content index system just to get a quick overview of how it works from a code perspective. There's really one service that we need to interact with, and that's index service. And the index service has a few methods. There's the update method, which is concerned with basically collecting all of the index entries for a piece of content and then putting them in the database, removing the old ones if they exist and replacing them with the new ones. There's also a query system that we'll get into a little bit later. It's not super important for what we're doing now. There's obviously some delete functionality because we need to be able to delete records in order to update them. And also we'll be deleting records when they get moved in the CMS. The update method takes this index builder, and the index builder is really just a simple utility for collecting all of those rows of data. So basically it's what's responsible for collecting this information, those little pieces of information that eventually become rows in the database. And so what we need to do is use index builder to create those rows for a piece of content. If I open up the dependencies here, if you can see that, there is no dependency on Optimizely in the blend.contentIndex project, which means that Content Index doesn't know anything about the Optimizely CMS system, so it is up to us to bridge that gap. So we start by bridging that the gathering phase using index builder. Now there's a couple ways we could go about this. We could create a service that knows about our different page models and can interface between the page model data and the index builder. And arguably, that's sort of the more pure functional way to do it, because I, for one, am a fan of always making sure that my content models are really dumb. I don't like having a lot of logic in them. It just seems to cause problems. But looking at this holistically, I think having the content model be the one who knows how to interact with index builder and build the index makes a lot of sense and is a lot simpler. So that's the route I'm going to go. So in order to bridge that gap, I want to introduce an interface that knows about both content and index builder, and then have my models actually implement that. So we'll create an interface. We'll just do it right in the pages because I'm only indexing pages. I don't care about blocks. We'll say we'll call it I have content. And then we're going to have the blocks, or excuse me, the page models themselves implement this. And so we'll just put a method on those models. We'll say, actually, we'll call it, I don't know, build index. It will accept an index builder. And then they will, the model itself will be responsible for implementing that. So now, the nice thing about this is that I can start at sort of the abstract page level. I can put it on here, implement this interface. I can make it virtual, if I could spell. And then here I can index, the type of content that every page has, things like categories, content type. And then on the descendant pages, if I have more information I want to add, I can override it, still call the base method, and then add more stuff to the index. But let's start with that base piece of content, the abstract content here, and index some basic information about the page. So I think the first piece of information I'm going to index is the content type. And the way we get that is by calling getOriginalType. It can be, not index builder, it would be on this. Remember that this is an instance method of an abstract content page, and so this is going to refer to a piece of content. So when we call this .getOriginalType, if you recall from previous videos, Optimizely, when it creates content in memory, when you get a piece of page data, it's not the original type that you think it is. It's a proxy type. And so if I were to just go this.type, I would get that, I guess it's get type. This would get me the proxy type, which I'm not interested in. But Optimizely provides this extension method called getOriginalType, which will skip the proxy object type and give you what you're expecting, which would, in this case, would either be home page or general page. Now I'm just going to go up the chain until type is not page data, because everything in here is going to be page data. I don't necessarily want to index that. I'm going to loop through that, and each time I loop through, I'm going to get the sort of parent type. Let me see here. What is it? Base type, excuse me. And so I'm kind of crawling back up the chain. And it's complaining because type here, let's see, might be null. So I'm going to just add a check here. And that fixes that. So now Index Builder has a few methods here. We have add, and we just add string values. So I'm going to add type, and we're going to say type.name. And I'm just going to use name, not full name, because I want it to say home page or abstract content page. I don't necessarily want to index the whole assembly name and DLLs and all that stuff. So having the content types index can be very useful because very frequently you just want blog posts, or I just want article pages, or I want everything except the search page or something like that. It can also be beneficial to index categories. Anything that is page data in the CMS will have category data associated to it, whether you're using it or not. So we can check that. It will just be under this .category, which gives you a category list. And the way you can loop through that is just with a for each. Wow. Cat in this .category. Also super annoying that it's category, but it's, it's actually returns a list of things. It should be categories, arguably. And we'll just do index builder .add category. And it will be cat toString. Now, cat is actually going to be an integer. So a category list, when you iterate it, just returns the IDs of each category, and each category has an integer ID. It's important to note that categories are a built-in concept in the CMS. They are different from content, though. Categories are not translatable, and they are not versionable. And so there's some popular workarounds for that, but just something to keep in mind. It's built in, it's convenient, but it has some drawbacks. So let's take a look at where categories live in the user interface of the CMS. So if I log in here and go to edit mode, if I go to a piece of content and go to the all properties view and go to the content tab, it's right here at the top. It says add one or more categories. Right now, if I click on it, it doesn't do anything. And if I click on this, it gives me an empty block because categories are not like tags. You can't just type them in at the page level. They have to be managed at the admin level. So we have to go into admin first, go into config, and categories. Now categories, the built-in category system in Optimizely are hierarchical. And so you can create like sort of root nodes for the different types of categories you have, and then create child nodes to those that are the categories. There's a lot of stuff you can do with this. I'm going to create a root category. I'm going to call it post type. And actually, I got that mixed up. I like to make names that are sort of like identifiers, but it doesn't really matter. It's pretty arbitrary. And because this is going to be like the root category for child categories, I don't want this one necessarily to be selectable. It doesn't make sense for someone to say, this page is a post type page. That's not a thing. So I'm going to create this category, and then I can create subcategories. And we'll say this post type is about, we'll say Optimizely. And this one will be visible and selectable. Let's create one for, I don't know, we'll say front end. It's kind of generic. Let's create one for SEO. So that's how we create categories. Now, if I go back into my content, I went ahead and created a couple just example articles with no real content. There's getting started with SEO. Now I can go into my all properties view, go to content, and when I click on this, I get my options. And so this is a front end article. Publish that. I see I have new C# features. I don't have anything about .NET, so I'm going to jump back in here to categories. We'll create one for .NET. and jump back into edit. Content. I've got some CMS articles in here. You can assign multiple. As you probably noticed, these are checkboxes and not radio buttons. So let's say these are .NET and Optimizely. Same for this. Now you might have noticed that we've implemented this interface, but beyond the implementation on the abstract class, there are no other references to this, so nothing ever calls this function. And so we actually need to implement that interface between I have content and the content indexing service. To start with, I think the easiest thing to do would be to create a scheduled job that indexes all the content in the site. Once we have that running, we can verify that we have content in the database, and then we can add some content events to keep that content database in sync with the actual content. At its core, a scheduled job is basically a function that runs in a background thread, can run for a very long time, and can be made to run on a schedule. So most of the time I see scheduled jobs being kind of one of two categories. Either it's something that just needs to be run periodically. So maybe it's calling an API or refreshing some content, clearing a cache, whatever. It just needs to run every X period amount of time. And then there's sort of these ad hoc scheduled jobs that are, maybe they take a very long time to run, but they don't necessarily run on a regular interval, and we just run them when we need to. That's sort of that ad hoc method. I see this falling into that ad hoc category. Once we have the content events hooked up, we shouldn't have to keep the index in sync because the content events should do that. But I know from experience that sometimes things just get wonky for whatever reason. And so it's good to have a scheduled job that can reindex everything. It's also a great way to get that first initial bunch of content in. Otherwise, you'll have to go through and publish every single page in the site, to get the content events to do it. Whereas maybe here we just have a job that does it. And so that's what our scheduled job is going to be. It's going to be reindex all the content in the site just whenever we need it. The other important thing to know about scheduled jobs is that when they run, there is not necessarily an HTTP request context associated with that run. If it's running from the scheduler, obviously there's no web request. If there's no web request, there is no current site definition. So we'll see that when we get into this, but I see that happen a lot where someone will do site definition.current, and what site definition.current tries to do is look at the web request to figure out what domain you're on and figure out what site should be serving that request. If there is no domain because there is no web request, it will try to find a host that is the star host and maybe assume that that's the current site. But if you have not set up a star host, it won't be able to find the site and you will get back null. And I've seen a lot of scheduled jobs that just throw a null exception. And so we'll avoid that. So to get started in the code, I'm actually going to create a new folder in Business, and I'll just call this Content Index. And everything that's in this folder is going to be related to connecting the CMS to this content index system. And we'll create a scheduled job. And let's call this, we'll call it reindex site scheduled job. Now, in order to implement a scheduled job, you need two things. The first is we need to extend, I believe it's called scheduled job base from the episerver.scheduler namespace. Now that is an abstract class with an abstract method that we need to override, which is execute. Execute accepts no parameters and returns a string. The string is basically a status message that you'll see in the admin. So I'm just going to put OK there for now, just to have that be a complete method. The second thing we need to do is we need this to be, I think it's called a scheduled plug-in with a capital I. Yes. And so this basically tells Optimizely that this is a scheduled job. It's going to look for both of these things. It's going to look for scheduled plugin as an attribute, and it's going to look for scheduled job base as the base class. And so there's a few things we should set on here. We should definitely set display name. We'll call this reindex site job. It's also useful to add a description. So we'll say reindex all content into the content index. And as I've said in the past, anytime you can set a GUID, you should set a GUID. So let's generate a quick GUID using GUID to clipboard. By the way, that is also an open source project now. I put that out on my GitHub if you want. It's pretty handy for just generating tons of GUIDs really quickly. And then the last thing, I think it's default enabled equals true. That way it will show up as being available as a job that you can run by default rather than having to go into the settings and turn it on. So with this done, we technically have a scheduled job, and I am going to show you real quick where that shows up. So let's launch the site. The new CMS is very fast. It is not instantaneous. All right, the scheduled jobs are under admin, scheduled jobs. You'll see there's a whole bunch here that are automatically in here. These are just internal jobs that are part of the CMS. You might notice there's a message up here saying automatic scheduling is currently disabled, and all these things are just listed as idle, and there's not going to be, none of them have been run before or anything. That's because in local development, a lot of times we actually like to not have those run just because they're not really that necessary, and it can be kind of a pain. In fact, if you look, let's see here, where we have this. Yeah, in the configure services by default, when you create a new Optimizely site using their CLI, it's going to have services.configure scheduler options, and it's enabled equals false. So we're just disabling the scheduler just so we don't have a bunch of scheduled jobs running on our local machines that don't need to be running necessarily. So I said, here is our reindex site job, and I can hit start. It's going to run, and it's done, and there's that OK message. So that's the basic idea. So let's jump in here and start actually implementing this. So first things first, we do need to take on some dependencies, and in recent versions, I mean fairly old versions too, but recently you are now able to inject dependencies into the constructor. Never used to be able to do this. You'd always have to do the old method where you would do something like private injected content loader, something like this, and then in your scheduled job you'd have to say loader equals content loader.service, and then you could actually load content. In more recent versions of the CMS, you can actually just inject it into the constructor as is preferred. And then I don't need to do .service, it's just already there. So, but we will need an iContent loader. We also need a iSite definition repository. We'll say sites. And the last thing we need is a, what is it? iLanguage branch repository. Yes. We'll just call this, I want language repository, guys. Okay, and then I'll actually store these as fields. So for this scheduled job, what I want to do is I want to loop through every site in the CMS. Right now we only have one site, but in the future we may have multiple. So I'm going to loop through both of, or however many there may be. I also, once I get into a site, I want to loop through all of the languages that are enabled for that site, because currently the site is, single language, but it may become multilingual in the future. So we need to account for that. So I'm going to loop through all the languages and just make sure I get all the content for all the languages. And that's why we're taking on all these dependencies. The site definition repository gives me a list of sites. The language branch repository gives me a list of enabled languages, and then content loader, as we know, loads content. right, let's get started. Like I said, we're going to loop through every site, and then for each site, we're going to loop through every language, and then for every language, we need to loop through the entire content tree in order to index that content. So I'm just going to write it all out here right now, just to keep it all in one place to start with, and then we maybe do some refactoring later. So let's go to the sites.list. This will give me a definition of all the sites. Also, naming the service sites was really stupid, so I'm going to change that. And I'm at the same thing up here. And then I can call this sites instead. I think that's simpler. Sites. Yeah. Now again, we need the languages. I don't need to query for the languages for every site because it's universal across all the sites. So I'm just going to say languages equals language repository.list enabled. I don't care about the disabled ones. Maybe I should, but I'm just going to do the ones that are enabled. Now I think what I'm going to do is I'm going to spin this off into a separate function just to keep this top part a little bit clean. We'll say index, site, and language. And so we have a site definition. Call that site, and then we have I think it's a language branch, language. And so I'm just going to say index, site, and language. Oops, goes site, lang. I guess I need a body to this method, don't I? So we want to recursively go through all the content in a site from the start page in a particular language. There are many ways to do this. I'm going to show you my preferred way, and I just prefer this way because I don't particularly like recursive functions, at least not in C#. And so what I like to do is instead of using recursion to sort of make a magic stack for me, I like to be explicit and have a stack that I use. So what I'm going to do is create a stack of I content. I'll just call it stack. And then I'm going to push the start page onto the stack, which I'll do in a sec. Now basically to simulate the recursion, I will do a loop as long as something exists in the stack. So stack.count is 0. That means there's something in the stack. Yeah, I'll accept that. That's pretty close to what I want. I'm going to call it page though. I'm going to pop off whatever is at the top of the stack. I don't particularly care about the order. I just want to pop whatever's off. I will process this page. And then I need to queue up all of its child pages and push those onto the stack. No, I called it loader. So we call loader.getChildren. And I'm going to do page data. And I need the content link, which is going to be page.content link. And then because I am doing a particular language, I want to pass in that language. So we do pass in the culture. Now I have a list of child pages. And I can just do, loop through each of them. Emma stack.push, and we're going to push child. In fact, this doesn't actually need to be I content. This could be page data because I know everything is going to be page data. So we'll just fill in one quick thing here. We need that start page. It's tempting to just do start page equals loader.get page data site.start page. That might actually, that will work the vast majority of the time. There are some weird edge cases where maybe this doesn't work for some reason or another. I prefer to be just a little more guarded where I will basically check to make sure I can get that page. So the first thing I'm going to do is check that that my site.start page isn't somehow null. Oops. So it should be content reference dot is null or empty. So if for some reason the start page doesn't exist, I don't think this is possible, but I still like to guard against it, because who knows, maybe someday it will be. Always just check. And if it is, then we just bail out. We don't need to process anything here. So then we can do the same thing here. Instead of doing loader.get, I really prefer loader.tryGet. And so we're going to do the same thing. We're going to pass in the start page. I want it in a particular language, so I'm going to do language.culture. And then I need to give it an out, and we'll call it start page. So this is basically saying if it loads correctly, do some stuff, but I'm going to bail early. So I'm going to say if it does not load correctly, return. And then I can push my start page onto the stack. And now the rest of this should work. Now, before we get any further, I want to see, is this going to work at all? And I can tell you now, no, it is not going to work at all. And we will see why. But I'm going to go ahead and start this up and run it. Okay, there's my reindex job. I'm going to hit start. Unable to resolve the for type blend.content.index service. So what that's saying is the CMS has no idea, or not necessarily the CMS. What it's saying is that the inversion of control, this dependency injection service, has no idea how to resolve index service, and that's because I haven't told it how to resolve index service. And so we need to set up some service definitions. So the way I like to do this is I like to bundle up all my service definitions that are related to a particular feature in that feature. So I'm going to create a new class, and we'll call this, it's called content index startup extensions. And so what we're going to do is we're going to write extension methods off of this services, this iServices collection. And we're going to kind of follow the same pattern of add. So let's go back into this. We're going to make this static so we can make static methods. Public static iService collection add, we'll say content index, this iService collection services, return services, and we need to import some namespaces from Microsoft.extensions. Now then, what services do we need? Well, we need index service. Index service depends on content data store factory, and that takes a connection string. So what I'm going to do is I'm also going to require iConfiguration. I think that's what it is. From the Microsoft.extensions.configuration, don't use the castle.core one. I'll call that config. And so I know from having written the content index system that this content index data store factory has to be singleton. So I am going to add singleton, and I can't, it's tempting to do this. Problem is it's not going to be able to resolve the connection string. That's what I need iConfig for. So instead, I'm going to add singleton new connection string config. Actually, I think it's, yeah. And that connection string was actually in here, and it will be connection strings : episerver DB. There we go. So now there will be one content index store factory. So that's good. That's done. I need to close some stuff here. So back to index factory, that data store factory is the only dependency that has. So, and because I've already added that to the DI, I can just add it as a transient. And because it knows how to resolve content data store factory, I don't need to do anything more. And I'm adding it as a transient because basically, unless you specifically know that something should be a singleton, you pretty much should always make it transient. And the reason for that is if I, added a service as a singleton, and one of the arguments it accepts in this constructor needs to be transient, like maybe it's tied to a request, well, I've effectively made that dependency singleton too. So I add singleton here on content data store factory. Basically, any dependency that has is now effectively a singleton as well. And so that can cause problems. It's just safer to do add transient if you don't know. So we need to actually go into our startup and add to our list. Now, we're going to, add content index. Now, this does accept an I configuration, which we have available. It's being injected into the startup, into the class. So pass that in. Just give it another shot, see what happens. Loading, 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 start. And done. So it actually ran. It probably went through all the pages. We don't really know. We don't get a lot of visibility into what these things are doing. I'm going to close some of this stuff and open up my scheduled job. So we still have this to-do to process the page. I think I'm actually going to put that in a separate function here. Private void process page. So, as you'll recall, we created an interface called I have content for things that should go into the content index. So what I'm going to do first is see if this page data object actually implements I have content. So if not, page is I have page content. We'll call it indexable. Let's bring in that namespace, lots and lots of namespaces. I think I need to actually put that in parentheses. Actually, I don't need to have the brackets there. There's nothing to do here, so I'm just going to return right away. Otherwise, I'm going to say indexable.build index. So now we need an index builder. So we'll just create a new index builder. So the identifier, now this is kind of arbitrary because content index doesn't care about the CMS. I'm going to use the ID of the page as the identifier. I'm going to say page.contentLink. I'm specifically going to do .id.toString on the off chance that I get a content link that is not published or something. I really just want the ID. Now, we could just leave language. Actually, we cannot leave language as it is because we need to know that. I think I can do language.language, and we'll just do language.name. And that's because page data is localizable. And then store name, it defaults to the word default. I'm actually good with that. I'm not going to have a separate store name. And the reason we have a store name is maybe you're indexing content outside of the CMS. It's pretty common to see something like that where not only are you indexing content in the CMS, but you could potentially be indexing content outside of the CMS. So we pass in our index builder, and it's going to build all that information about the page. And then when that's done, remember we have our index service, which you're not yet using. Let's do index service dot update, and then we pass in the index builder. And that should do it. So let's try this again. Schedule jobs. Let's start this. Thought it stopped. Okay, it's done. Let's take a look and see if we actually have anything in the index. Oh, the anti-malware executable decided it's the most important thing on my computer now. Now, I happen to know, because I wrote this, that all of the content index entries go into a table called blend_index. I'm just going to query this and just see if there's anything in here, and there is. So here we are. So I mentioned the identifiers are the IDs of the page, so that looks probably correct. We have one homepage type. We have several general page, and then all of them implement abstract page. This all looks good to me. The categories, as I mentioned, are being indexed as integers, although technically they're strings in the database because just to keep it simple. But yeah, this all looks good to me. This is how it is being represented in the database. All right, so this appears to be working. That's great. I did want to cover a couple of things about scheduled jobs. Now, the first is that scheduled jobs can and generally should be stoppable. What that means is that I can start the job, realize that there's a problem or whatever, and hit stop, and the job will actually stop. I see this implemented incorrectly all the time, where the scheduled job will report that it's stoppable, but we never actually have any code anywhere to stop the job when stop is hit. So the way we do this, I'm going to do this dot is stoppable equals true. I just want to be explicit that yes, we can stop this job. I'm going to have a variable called, let's make it a bool, we'll call it should continue. And what I'm going to do is at the start of my execute method, I'm just going to make sure that that's set to true. We want to make sure that we should continue. And then basically, everywhere where we might have a loop, we just need to double check. If we should not continue, we're going to break out of this loop. Same thing here. And I'm even going to come down here where I'm looping through the stack and basically put in that same check. If not, should continue, we're going to break out. So if this should continue variable ever gets set to false, all the processing should stop. How do we set that to false? Well, there is a method we can override called stop. And I'm not even going to bother calling the base method. I'm just going to set should continue to false. So this allows me to stop the job. Now, this job doesn't run long enough that I could probably demonstrate it in the CMS, but you'll see you hit start, there's a stop button, you can hit stop, and should continue should break the process, and it should stop. The second thing, you'll notice that in the execute method returns a string and we're returning OK. And OK is what shows up as the last result. While the job is running and at the end of the job, we can return or pass through status messages to the UI to kind of give an idea of where we're at. And so it's not a bad idea to have some kind of status message. So let's just do this. Let's just count the number of pages we've processed. So we'll say pages. And at the start of the job, I like to just be very explicit and set that to 0 up front. And then for each page that we actually process, I'm going to say pages plus equals 1. And then there's a method called, what is it? It's on status change that we can call to pass data back through to the UI. And we can say processed underscore pages. Maybe not capitalize that. And then we can actually do kind of the same thing at the end here, except instead of calling the method, we can just return that. This gives us at least a sense of what the job is doing, that it's continuing to work. On a job like this, let me run it quick. Maybe. Might have clicked that too fast. There. So it says process 7 pages. Let's say there was 1,000 pages in the CMS. Maybe I've run the job, it says processed 1,200 pages and the amount of time was 10 minutes. The next time I run it, it's going to be saying how many pages it processed. I can kind of mentally do that math to figure out roughly how long the job is going to take. I know I've got about 1,200 pages. It took 10 minutes last time. I'm 600 pages into it. I'm about halfway done, So it can be helpful to just kind of return those status messages. And the two ways you do that is by returning the string here at the end of the execute method and by occasionally calling, wherever it is, on status changed. So we have our index job running, and there's one kind of glaring issue that I just realized I totally forgot, which is that right now we are only updating content. So if we delete pages or whatever, it's going to leave it in the index. And the simplest way to fix that is to what did I call it? Index service dot delete. And delete can either take a content query or an identifier to delete a specific piece of content, we actually want to do a content query. And the content query really, I think all of this is actually going to be just fine as it is. This will just delete everything in the database. Now, if we had multiple stores, we would probably want to, pass in the store name or something. But the important thing is we basically wipe the index clean to start with, then we go through and re-add everything. Otherwise, it could potentially leave orphans laying around. So just wanted to clear that up. The other issue with doing this indexing through a scheduled job is I don't want to run the scheduled job every time I update a piece of content. I want that to sort of happen automatically in the background. That's how it works with most content indexing systems, such as search and navigation. It just updates kind of magically in the background. So the way we do that is by tying into the Optimizely content events system. So, and the way we tie into events is through an initialization module. An initialization module is basically a piece of code that runs when the site starts and also can run when the site shuts down. So let's create an initialization module for content index. And it's pretty simple. We just create a class. The class can be called whatever you want. I'm going to call this content index initialization module. So the way we create an initialization module is we make a class, can be named whatever you like, and we need to extend initializable module. The initializable module requires that you implement initialize and uninitialize. And we also need to have an attribute called initialization or initializable module right here from the framework. So from here, we can actually get a reference to the content event system. So basically, when the site runs, we will get initialize. And when the site shuts down, it will call uninitialize. And so we need to get a reference to the content event system. It's not a good idea to take dependencies in an initialization module, like through the constructor. Instead, we'll use service locator to get that. And so I'll say events equals service locator. And we need to use the one from episerver.servicelocation.current.get instance. And this is, I think it's content events. Yes. So now what you can do is you do events dot, and you've got a bunch of different events that happen. You'll notice that all of these events seem to have like an event that ends in ed, as in past tense, and then there's one that ends in ing, as in present tense. So, checking in content, checked in content. There's let's take a look at published. There's publishing content and published content. The differentiating factor basically here is publishing content actually happens before the content is fully saved and published. And so you will get the content as an argument to this event. You can still change it at this point. Published content, the publish has already happened, and the content event or the content reference that you get in the event is read-only. So that's the important thing. The ones that I'm typically most concerned with is publishing. I do occasionally use save, like saving and saved content. These happen pretty frequently. So my one caveat to this is every time someone like edits the title or something and clicks away, that causes a save. Or they're typing something and maybe it saves as they're typing. This one can be pretty chatty. So a lot of times I actually prefer to use publish. And actually I'm going to use published content because I don't plan to change any of this content. So we're just going to add a new event called published content. And then really, like, as far as best practice goes, it's not a bad idea to actually remove your events when you're done to prevent leaks. I don't actually know if this really matters, but you see it all over the place. It's not hurting anything, so I'm going to go ahead and do that. So on this published event, this is where I need to update the index. So I need to get a reference to the index service. I'm going to do the same thing here. Get instance of index. It's content index service? I don't remember. Let's look. I think it's just index service. right? So we need to do basically the same thing that we did in the scheduled job in the process page. So now page is actually going to be, I'm actually going to just do this, var page equals e.content. This will give you the content that was just saved. I have content is in the models namespace. And content here is actually coming as iContent. iContent is not necessarily localizable, which is why language is throwing an exception here. What I think I'll do is I'll say as page data. In fact, I'm going to do this. If not e.content is page data, and then we're going to take that page, return. If page is not content indexable, then we don't do anything. All right, now we have content being automatically updated when we save content in the content index, I mean. Okay. All right, now we have the index updating automatically when we save content. So we're done. Mission accomplished, right? Not exactly. There's still a couple of events that we need to care about. And those events are content being deleted or deleted and content being moved or moved. Now the deleted, that seems pretty obvious, right? If we delete content, we don't want it in the content index. We only care about published content in our content index. So if it's deleted, it needs to be deleted from both places. Moved maybe doesn't seem like it makes sense, because if we look at our model and what we're actually saving, we're saving the content type and the category. We don't really care, like, you know, if it moves in the tree, that doesn't affect the type or the categories. Except that when you delete content in the CMS, the first step is actually to put it in the recycling bin, and that is actually a move. So if I open up the CMS, let's jump into the tree. Move to trash. It even says move to trash. When I do that, the content still exists. It's just, it's in this hidden, it's actually a child of a hidden trash bin node now. So that was a move, and the move event will cover that. And if I hit restore, it's going to put it back in its original place. That is also a move that comes through as a move event. So we care about both of those events. So let's jump into our initialization module and add those events quick. So again, we want, what's it called? Let's start with moved content. I'm just going to take the default there, and we need deleted content. Let's start with content moved. Now, I basically need the same stuff as I do on published content, so I'm going to grab this stuff here. We're going to get a reference to index service. We're going to make sure that this is a page, because I don't care if they move blocks. We're not indexing blocks necessarily. And then I want to make sure the page is indexable. And then I need to decide, basically, is this being moved to the trash bin or not? Because if it's being moved to the trash bin, I want to delete entries. If it's not being moved to the trash bin, I just want to update entries. So the way we do that is on the event, on the content event args object, there is a target link. And that is basically the parent node under which this one is going to be dropped. And what I'm going to do is I'm going to compare this to content, content reference dot wastebasket. So if the target is the wastebasket, then it is being deleted. So if it's being deleted, we could go through and recursively go through all the pages underneath the child of, or all the children and recursive pages underneath e.content. But we have a content index. So what we should be doing is indexing the content in such a way that I can say, just delete all the nodes that are a descendant of this page. So we'll do that in a second. Otherwise, I need to go through, and I actually do need to go through recursively and update all of these pages. Now we've done that in the scheduled job here, where we have this process page, basically. And so actually the process page is basically for a single page, but we have index, site, and language. We could pull out this part here, or maybe not necessarily the site, but we have a recursive function here that starts at a page, which just happens to be start page here, and then recurses through and calls process page. So the fact is I already have this functionality, just not in like a usable place because it's in the scheduled job. So I think what I'm going to do is refactor this out and then come back to this module to do the recursive update. All right, so basically what I want to take out of this is the stack, all of this, and this process page. And I think the way I'm going to do that is I'm going to create a service. I'm going to call this, let's call this Optimizely Content Index Service, because it's sort of the bridge between Optimizely and the Content Index Service. I'm not going to bother with the constructor yet because I don't really know for sure what I want. But I am going to grab this much. Right now we're accepting a language branch. I don't think we actually need that. Let's do this. Okay, we'll say re-index tree. We're going to take page data of some kind. We'll call it page. I'm going to paste all this in. Actually, I'm going to cut it out of here because I want to use this. Let's take that stack out. And I'm going to call this start page, actually. Let's bring in some namespaces. Now, there's a few things in here. Okay, process page that I can bring over. Let's do that. Oops, right in here. Wrong button. Paste. Let's bring in some more namespaces. Okay, so I know I need index service. Let's go ahead and bring that in. Oh, for Pete's sake. We're going to use the content index service. Oh, maybe that's right. I just called it index service. Okay. Make that a field. So that fixes that. We also need a content loader. And I just called it loader for some reason. I usually don't do that. So we need language, but the thing is, we already have page, and page has a culture associated to it, so we can actually do this. I think it's actually just language. So we don't need the language branch here. We can just get it off of the page, the content we have. The rest of this stuff should continue, pages, on status update, or on status changed. All of this stuff is really tied to the scheduled job, but I don't necessarily want to lose this. So I think what I'm going to do is create a context object that we can pass into this function that includes some of that data. So let's do this. We'll do page tree update context. So we need a couple things. And I'm just going to make this stuff public. We need the pages. We need whether or not it should continue. And then I need something to replace this on status changed. I'm going to use an action for that. I'm just going to call it on status changed. I'm also going to make it optional. Get set. And then I'm going to require this as a parameter. Context. Now I can come in here and say, should that continue? Pages, dot pages. And then here I can actually do context dot on status change dot invoke. So basically, if they provided an on status change, I will actually call it with that to pass that data out. So now, to fix my scheduled job, I'm just going to add this as a dependency, and we'll call this Opti-index service. My goal is I eventually will remove maybe some of these other dependencies if I don't need them anymore. All right, so we have the start page, optiservice.reindexTree, start page, and then we need a new page tree context. And we're going to say onStatusChange equals this dot onStatusChange. So we can actually just assign directly to this function because the function matches the correct signature that we're looking for. You could also do something like message this dot onStatusChanged message. That works, but it's just really unnecessary. So instead, we'll just do this. It looks weird, but it works. So having done that, now I can reference this Optimizely content service here. So I'm actually going to lose the index service for right now. And we'll do a different index service. I should have just changed that get instance of the Optimizely version of this. And then if it's updated, I can say, well, we need to reindex the tree for the page, and then we're going to pass in a new page tree context. But I'm not going to bother with that report progress because there's nowhere to report the progress to. So now this will do the same thing that the scheduled job is doing, just during the published event. Now here's a little caveat for you. These published events all must complete before the user interface will show that the page has been published. So right now I could potentially be updating a huge chunk of the page tree, and it has to complete all of those updates before the UI will show that like the move is completed. So it can make the editor experience pretty painful. If you're doing a lot of processing in an event, I strongly recommend you look into putting it into some kind of message queue and then processing them, in a thread somewhere else. So you're not holding up the UI, if your scenario supports that. So I'm not going to do that because it's a layer of complexity here that we just don't need. But, if you're doing some complicated stuff, really consider doing some kind of message queue or some, offloading it to a background thread or something like that. All right. Now, anytime we create a new service, we need to register that service. So let's go into our startup extensions and add it. Services. And again, I'm going to just do transient because, there's no reason for using anything other than transient. If we go to the constructor, it requires an index service and an iContent loader. Both of those are already handled. So this should be all we need. So once we have that done, let's go into our initialization module. And we have the process for when we update things during a move. We do not have the process for when we need to delete, the tree from the index. There's a couple ways to do this. We could, similar to how we update the tree, go through the content through the CMS recursively and update each individual record. But the content index can actually do bulk deletes. And it would actually be much simpler for us to do that. But we need a way to tell the index service, what page is a descendant of what page. So we can just say, delete all the descendants of page X. And the way we can do that is by indexing their ancestors. So the way I'm going to do that is I'm going to create a page, and actually I'm going to do this. I'm going to say an abstract content page equals this. And I'm going to make this nullable while page is not null. And then we need to add it to the index builder. Add. I'm going to call this ancestors. And we'll say page.content link.id.toString. And now I need to basically do page.parent page, but I don't actually have parent page, I have parent link. So what I am going to do is bring in a content loader. Now, I cannot bring a content loader in on the constructor because this is a content model, and I really shouldn't be doing anything in the constructor because I don't want to potentially throw errors. Also, it's just not going to work. Bottom line, so it's not going to work. So I'm going to just pull it from service locator inside this method because it's the only place I need it, and it just it doesn't need to be more complicated than that. So I'm going to do service locator.current.get instance of iContentLoader. So now I'm going to try to load this parent link, but again, I want to put in some checks to make sure that it actually loads correctly. There's no issues. I don't want to throw errors during this process. So I'm going to do, first we're going to make sure the content reference is not null or empty. And it's going to be the parent link. Now, parent link should really never be null or empty, but if it is, I'm going to break out. I don't want to continue with this. Then I'm going to try to load it. If not, let's say content loader. No, I just called it loader. Not loader.try_get. We're going to say page.parentLink. I want to load it in the same language, so I'm actually going to pass in the language as well. Out content. Let's just do iContent. I will say parent content. Not return break. So if I cannot load this, then we're going to bail out. And then finally, I only care about abstract content pages. So if parent content is abstract content page, we'll just say abstract content. And I'm going to negate this whole thing. If it is not abstract content, I want to break out. And so finally, I can say page is abstract content. So basically, this will roll itself up the page tree until it gets to the root node, which is not going to be abstract content, and then it will bail out. So now I have a list of ancestors. Is it ancestors? I think it's ancestors. Which we can query. So now I want to actually do this bulk deletion. So I'm going to do my index service.delete. Now, this method doesn't exist yet. I'm going to write this, but I think I can just use the content link to do this. So I'm going to go ahead and generate this method. We're going to go into this and change it from internal to public. And so in here, I basically need to do, similar to what I've done here. I just need to delete the page and all the child pages. So let's do this. We're going to create a content query. And this content query stuff is not super pertinent to Optimizely. It's just the example API I wrote, so I'm not going to spend a bunch of time on it. But basically, the way this works is I'm going to do new content query. Helps if I do new content query, and I'm going to match that new field that we just created, ancestors, and we're going to match it against the content link.id.toString. And then the index service that the content API comes with here, or the content index service has a method that will accept the query and will bulk delete basically anything that has this page as an ancestor. So that would be all of that page's descendants. So the nice thing about this is we can do the same thing on the delete method. So I'm going to actually pull all of this over. Let's get rid of this. Paste it in. The only difference is that we don't care. It's not being moved, so we don't care about the trash bin. We just know that it's being deleted. So we'll just do this to just make sure that if it hasn't already been removed from the recycle bin, through the recycle bin, then it gets removed.
Hey, it's me in the editing suite, I guess you could call it that. And I'm cutting in, even though it drives me crazy when YouTube videos do this. But I'm cutting in because I just think it's important to note that there are some bugs in the code I wrote during this episode. I recorded this thing in basically a 6.5-hour session with no significant breaks. And at the end, I was getting pretty shot, as you can probably tell. And the code I wrote was a little bit sloppy. So I just wanted to mention that it is a little sloppy, it is a little buggy. I'm going to push the code exactly as I wrote it to the GitHub repo, and then in separate commits, do some fixes and refactoring. I'm going to do all that off camera, but I just want to mention that so that you're not following along and then having the exact same code and wondering why the heck it's not working. It's not working because it's not quite correct. There's just a few things that need to be fixed. So pull those commits from GitHub and you'll have working code. But thanks for letting me cut in, and now to the outro.
So there you have it, an introduction to content events and scheduled jobs in Optimizely CMS in a somewhat real-world-ish scenario to give you a taste of what it's like to integrate with external systems through the CMS. I hope you found this useful. I hope it wasn't too much to trudge through. It was kind of a long one. Thanks for sticking with me, and see ya.